JCB, tractor, and so many things. So it has to identify all the objects properly in a given thermal image. Here you can see the domain shift. I think they both are on the same time which they have taken in. There is no color information in the thermal image at all, whereas in RGB image I can see so many color variations. For example, an auto can appear as green as well as a black color thing, like as a gold one, and if it's a private one, they can customize it to whatever they want. So yeah, without color, color gives me so many other information which thermal domain can't, and at the same time there are some information which thermal domain provides which RGB image can't. So best example would be night condition and foggy, rainy, these kind of images. Where in night I can't identify where an object is, like without light. I'm totally dependent on light source. If there is no light source, basically like we can't, even in a dark room, if we just let a person go through and I ask him to identify a laptop which is not turned on, he will struggle, he might even trip off, he might fall. So that is the kind of dependence. If he is having the night vision or thermal camera, it can light up the thermal. Basically, like we can't emission in a dark room. If you just let a capture go through and I ask you to identify a dark camera is not turned on, which is not a good struggle. It might even trip off, he falls. So that is the kind of dependence. These matches you see are nothing but the emissions that are coming out from the vehicles. So it's all internal combustion engines only, right? So the exhaust will be very hot at that particular time period. So even though the drone is flown from I think around 150 or 200 meter altitude, we are still able to capture the thermal radiations which an object is emitting down. For example, like the people even here who are standing more like representatives like ants or something, even they have heat signature. This is very clearly seen in night condition. I think I don't have that one. Okay.
Claim to have
This,
what's your superpower? Confidence is your superpower. Hey, look.
This is the web page we had developed. So this is again from various places, including Hebel and some of them collected near IISc itself, the bridges. So here you see like, except this part, I can't identify what object this is. Like unless I zoom in clearly. Even though if I zoom in, one part of the car is visible, maybe it can be an auto rickshaw as well, who knows. So I'll just open up the corresponding thermal image, check it out. The difference, you can see it very clearly, right? Here it can be a person or it can be a vehicle also. I can't identify, but here I can certainly say it is a person sitting on a motorcycle. He is not walking, but because the motorcycle's thermal emission is totally different from a human's thermal emission. These kind of information is critical in various applications like defense and even commercial applications. For example, I think Bangalore Traffic Police had a requirement to identify or count the number of images even during night time that is entering in the city and going outside the city. Surveillance purposes. So,
You are more capable than
those
your
kind of
type.
aspects, this is
First
a
one,
very
first one,
important domain to
is my
understand. So that's why we came up
my superpower.
with this particular algorithm which tries to effectively identify objects.
Confidence is
in
my
thermal
superpower.
images, even when they are not co-registered. So there are two
Adu
problems that we are addressing in this paper. I wouldn't be touching
Confidence
upon the
is my
main
superpower.
problem, that is co-registration.
Confidence is my superpower.
Because like I
Confident-
give some
confi-
prior thing that is dependent on the sensor. For example, blur cameras, when they say
Confidence is my superpower.
it was mainly for autonomous view. If you take it on
Sumner,
high altitude, the co-registration process
Sumner,
fails. So it's highly like
Confidence is my superpower.
object detection data sets.
Confidence is
even
my
the
superpower.
algorithms which we are using sensor fusion kind of approach. These terms might sound very like new, but these are the ongoing research on this domain.
Confidence is my superpower.
So sensor fusion requires like co-registered data, but domain adaptation doesn't. So if I have two separate RGB and thermal cameras, still I will be able to identify the objects on thermal camera much better using the RGB domain. That's what I'm trying to do here. So what I
Confidence is my superpower.
augmentation is what is interesting here. So this again popped
Stick.
out.
Confidence is my
In
superpower.
a funny manner. When we
Mike
were
is
just
directing
working
it.
on RCB images, it was for a
Confidence.
different
Hey,
application,
Raksha.
and we had corresponding
Confidence
thermal
is my
images as
superpower.
well.
Confidence is my
Just out of
confidence.
curiosity, we passed thermal images to the same network which was trained on RCB.
Confidence is my superpower.
And interestingly, it identified, I think, around 10 or 20% of the objects, even though it was not trained on IR domain.
Okay.
That gave us curiosity to explore, like,
Dami
why
uncle.
is it identifying? So that gives us information that it is highly dependent on the structural aspect. Like the
believe in
CNN
yourself,
also
you are
observes the
halfway
structural
there.
information, like an aircraft or a
Believe
car.
yourself.
This is a structure, it looks like a bus will be lengthy, a car will be only
Saak
so
sumne.
much. These kind of information are something which
ಸುಮ್ನೆ
CNN
ಇರೋ.
can capture.
ನಾನ್ record
That's why
ಮಾಡ್ತಿದ್ದೀನಿ.
it is able to predict on
ಇವಾಗ
thermal
ನಾನು
images
edit
as
ಇದ್ರಲ್ಲೇ
well.
ಮಾಡ್ಬೇಕು, ಸುಮ್ನೆ ಇರು.
That we try to
Believe in
extrapolate
yourself,
here.
and you're halfway there.
Further enhance
Believe in
the
yourself.
performance by converting RGB's image objects to grayscale. So if you think of these particular image are kind of grayscale. If I didn't mention, or if we just randomly sample some BTech student from maybe 4th year or 3rd year, ask him to say what this image interprets, he'll be like, this is a maybe grayscale image, man. It's just black and white. It doesn't have anything. That's what his immediate response would be like. Whereas here, that's the same kind of philosophy that we are trying to adapt as well. Color information is a bias as well. It gives you fine-grained picture as well as it acts as a perturbation for the models. That's what we learn from this work. Where if you try to remove the color information of objects alone, the performance improvement is quite significant. That's what we observe. Like if you there is an ablation study also. You might be wondering, why should I color only the objects? I can color the entire image to grayscale. That is much simpler, right? But there is an ablation on that. If I convert the entire image to grayscale, the performance improvement is there, but it's quite marginal, maybe 2-3%. But when I try to retain the color information of background, but remove color information only of the object, that gives significant bump up to like 7% is what we have observed in this paper. So that kind of again, if you ask, these are intuitive hypotheses that I am making, or even we are making from the IIS perspective, where we are saying color is acting as a perturbation. So we want to remove color information not from the background but only from the objects. That's what it is trying to do. After removing the color information, when I pass that image to the same adaptation network, these are standard adaptation networks which are called mean teacher architecture. You can check out. So there will be, this is again like a classroom scenario. So there will be a student model, there will be a teacher model. Two networks at the same time. But the training for student will be different from training for teacher, right? Because there won't be any bad propagation that is happening on the teacher. I will be deleting that teacher. Whereas I enhance the back propagation only for the student, I will update the teacher based on the student states. So this is a concept called exponential moving average. You can check that out. So these are some of the interesting things. This is used to transfer weights, not entire. If I transfer the entire weight matrix from student to teacher, then what is the difference between student and teacher? The weights are the same, right? I don't want that. There are some qualities of student which are quite good, which the student or teacher have to incorporate so that the predictions, the ground truth is much better. So this is on unsupervised domain adaptation technique that we focus on. Yeah, I think the corresponding paper is already published in some proceedings. You can check that out. And this is a data set that we had collected. We named it the eye, mainly because it collects information from infrared and electro-optical. The eyes can see only half RC coming, right? So that's why in the eye, infrared and electro-optical for different tasks. And what makes this data set quite interesting is that, if you observe this geographical map, this is the first data set that is collected through drone in the equatorial region. If you all know, India has the equatorial advantage. So here the heat waves will be much significantly higher, and this is collected during the month of I think May and April itself last year. So last year, if you remember, there was heat wave as well. In that period we collected, and there will be a lot of thermal fluctuations. difference. Between scenarios like desert and all, if you are deploying a model, there will be a lot of thermal fluctuation, that is the noise, which is not captured in the existing data sets, which I have mentioned here. FLIR, M3FD and Red Eye. These are taken from a cold region. M3FD is from China. It's mostly like rainy season which they have taken. FLIR again, it's a tropical region. It doesn't include any harsh weather condition. It has raining, in fact. Whereas Red Eye, it's again biased towards only one weather. No thermal fluctuation. That's the main difference. And yeah, here you can see the performance difference between of the network on three different data sets. That is FLIR, LLVIP and RIE, and the network that we propose. So CMD, D3T are two state-of-the-art networks. D3T again was a CVPR paper that was published in 2024, which we beat by I think 7% or 6% in the chart. So when we incorporate the augmentation strategy, that kind of clearly mentions that the proposed technique is not meant for a single network. It's a augmentation that can be applied for any specific use case or any algorithm. It's a plug and play kind of technique. So yeah, these are like why the need for adaptation. You might be wondering, wow, what is the need? Like why not just train and infer on thermal data alone? But when you do the domain adaptation, you are not losing the RGB information, but you are trying to learn the higher information as well. So here there is a concept of false negatives, right? Like in machine learning, you would have come across false negatives. So the model is just hallucinating. It's just confidently saying, yeah, this is an apple. If I say this is an apple, you'll be thinking, oh, this guy is just stupid. He doesn't know even this is a laptop. He's identifying it as an apple. So that's what happens even in machine learning. See, here it's clearly like we know it is a road. There is no object. It still is identifying it as some object. So this is a kind of bias that is there when you do normal fine tuning or normal training approach. But when you try to use two modalities at the same time, you are leveraging the fine-grained features of the RGB image as well as the structural information from thermal image. Then the false positives are totally removed. And this is a small motivation again for Gen AI I would like to touch upon and wrap it up. So this is, I don't know if this person is visible. She is Rajlakshmi Menon. She is the Director General of DRDO right now. So, and she was there for the conference that's happening at IIC yesterday. And she was brushing up and she was touching on the concepts that we discussed today right now. Generative AI, as we all say. You guys remember, like I told, there is a concept on super resolution. That's the same thing she is addressing in this slide. She's like, I have a geographical region. If I zoom in, the features will get blurred out. Like if there is a person or a tank, it will just get messy. You can't identify anything. But if you have a super resolution image, maybe putting a high-end sensor on the aircraft or fighter jet might not be a feasible approach. But if you have a network that can tackle this, why not? It's much safer. You are not putting the entire fighter jet or the sensor on risk by flying on enemy region, right? So that's what she's trying to address. And the below image here, she's trying to say it should be diverse enough to, not general enough to predict on all kinds of weather information, be it rainy, foggy, or either China region is again like the glacier part where you often tend to see snowfall and all, right? So the model should be able to predict even in that region. So that's what she is trying to motivate here. And the image on right speaks on the thermal image importance. So this is a image taken from an, I think, I don't know, 5 kilometer altitude or something. When we zoom in and pass the image to the model, it is identifying a tree as a person. So previously I spoke about false positives here, right? There's the same thing happening here also. Like it's identifying a tree as a person, but that's not supposed to happen. It has to identify a person to be a person. Or else, who knows, if we give direct control over AI for any actions to be taken. Say for example, if it thinks it is a terrorist and if it starts launching missiles or attacks, that can lead us to war, or sometimes like can happen anything. That should be prevented. That's it. The model's accuracy is quite important in these kind of aspects. Here I am speaking on defense by mainly because this place we have worked on, but there are also critical applications like biomedical, where the cancer detection and all these early sign disease detections, they are quite important. If there is any mismatch over there, it's a big loss for the hospital, as well as you are putting humans at risk, which is like precious than any other thing. Like money can be earned, but person cannot be bought back. Yeah, and thank you. And I'll be sharing some links for this hands-on. So can you just scan this? So this is a blog post or a small tutorial by Google itself on generative AI. They speak about generator and discriminator, all these concepts along with their diversions pretty much well in this one. The blog post covers that. Can you just scan it and let me know that? I would say switch over to the next one. So similarly, there are other blog posts as well. Lot of people like researchers in industry or academia, they do have their own Medium profile. Medium is again a blog post platform where they keep posting on all these recent papers or any of the groundbreaking research that happens. You can check there as well. So yeah, all these techniques, like the resource is widely open and it's available on the internet for everyone to access. Is it done? Like, can I for the next one? Is it not? Internet. It gives you a link with title saying Introduction to Machine Learning, Google for Developers. Click on the link, it will open up the advanced courses. So this is an introduction and some stuff related to Gen AI, GAN particularly again. So yeah, this is one more good resource to follow. And you can take image of this one and scan it. Like this is a hands-on session. Like it's a collab code which is open source by the authors itself, and it has comments which says what the particular code block in collab is trying to do. So this doesn't require any GPU from your computer. It purely works only on the Google server. So you can utilize the free access and try it out. You can maybe change the hyperparameter to see how it is working. Yeah, all this. If you want to change the optimizer, what is the effect? The process of generation can be easily visualized and can be seen here in this particular course, not course, code. vanilla GAN. It is not a conditional network. So there you will see the loss curves as well. How a discriminator's loss function is varying and how the generator's loss function is varying over the period of time. And they also provide at intermediate iterations what the network is trying to generate when we are giving an image. So I think they have taken 3 and 5 as an input. It's kind of confusing, but the network still learns it much better. So yeah. Finally, you will get the predictions for given set of images. We can still change the data set here. This is on MNIST, but you can use any other data set. I think for GAN, there is some animals data set as well. Even in horse, you can still try to ask it to predict a dog on the same kind of structure or color information, patterns. These kind of fancy things are still possible. Yeah, this is conditional GAN. So here you will have the independence to condition your image generation process. Maybe text or any other thing, but here it's only for text which they are providing. So both of the codes will have comments and specific descriptors. So I think it's mostly self-explanatory based on, like, I don't know if you all understood or not. Like, if there are any doubts, feel free to name. So yeah, I think that's it. Thank you for the attention and having me here. So, any doubts pertaining to the slides or any concepts which I discussed which you didn't understand? Future of robotics is picking up a lot nowadays, especially for the humanoids and leg robots, the quadrupeds and all. When it is trying to move, it is trying to this process of 3D reconstruction using nerve and Gaussian slotting. They are right now in place. So GANs and diffusion model are also used. In fact, they are not like very outdated, but yeah, they are used in these kind of places. And future scopes, yeah, it is applicable in all fields of domain that we can need, including education, defense, just like I showed, and yeah, all the domain, medical images. So wherever you use data is a key component, right? Without data, we can't train any network. So if something is giving us data quite simply, why not leverage it? So the process of Gen AI, I think, will sustain for a long period, and it's a ever growing domain. It's not a stagnant thing. Next, I think they've been trying to make how the network simpler so that maybe it can run on edge device like laptop for generating images. That's what I think Apple is trying to do. If you are following their GitHub repository, their recent approaches are more like focusing on the edge device moreover than building large models. GPT also, the GPT OSS, even though it had so many drawbacks or flaw points, the main key point they focused on is open sourcing the network, the model, and they have claiming it to work on an iPhone or any device which has 16 GB RAM. That's all. It can still, like the ChatGPT can work on a 16 GB device. It's quite interesting. Right? This is how the fields which are the research community is trying to keep, right? We can gain the knowledge. YouTube maybe the easiest way, I don't know if the funding is still there. Project funding, we fix in and they give some funds to. That is a question. They can't fund every college. Even for IAS, like we have some agreements. If IAS itself is struggling, then I can understand the PQ colleges. Like the problem is even there, the supercomputers that we have are having Tesla cards. Tesla cards are okay now. They are using 16 or 32 gigs of VRAM clusters. But right now, the ones OpenAI is using is 800. There are a lot of like 800 clusters. They are beast altogether. You can't compare cat and a dragon, right? It's more like that. CPU is a hard constraint for all this machine learning. They are trying to minimize this. That's why all this edge deployment and edge training use cases. India is quite live. There is no other doubt like kind of this. You can read the paper, the Generative Adversarial Network. Hence, this is the paper that we discussed today. Just type in Google Generative Adversarial Nets plus archive. That will give you the paper. So that is the original paper that we saw today. Yes, sir. Sure, I will share. That I don't know, but I'll take it. I'll send it.
shared one article. Actually, now article summary session from 12 to 1. Now you are giving for 30 minutes. 12:15 to 12:45. Just now you have to, whatever you covered, same thing covering in that article. Now discussion, actual discussion is after discussion you have to give the presentation with 2 to 3 batches. You have to form the batches, 5 members or 6 members each batch. 1 or 2 batch you have to give 2 to 3 minutes presentation. Now you are not giving any present, just you have to discussion among yourself. Then you have to come with some conclusion. You have to come with PPT, then you have to give the presentation. After the second session or tomorrow also for this one. Okay. Now check that article. I will share the template also. Just you have to discussion among yourself. Form the batches. That is your wish. Minimum 4 to 6 members form the batches. Among the batch, you have to discuss among yourself regarding that article.
Just for the article summary and the reflection journals, you create your own group. So for reflection journal means whatever speaker has given the session, on that you have to summarize the sheet that we have to upload it. And article summary means any one paper will submit, and for that you have to summarize the sheet, format we will give according to the other AIC. And then you have to forward the summary.
Both are different. Yeah.
For both the things.
For both the things, yeah.
This doc format I have shared with you. Both the formats are there in that application. PPT.
Article is PPT. 5 to 6 slides.
Articles ಎಲ್ಲ PPT reflection journals ಇದೆ. ಇವತ್ತು ನಾಳೆ PPT ಮಾಡಿ ಆರ್ಟಿಕಲ್ ಡಿಸ್ಕಷನ್ ಗ್ರೂಪ್ ಡಿಸ್ಕಷನ್ ಮಾಡಿ ಇಲ್ಲಿ ಬಂದು ಅವರು ಜಸ್ಟ್ ಕನ್ಕ್ಲೂಡ್ ಮಾಡ್ತಾರೆ. ಹಾಂ presentation. 5 to 6 slides.
5 to 6 slides, just overview. Same thing you have to display in your projector, and you have to display team number, so title, all those things. Yeah.